everyone, and my special greetings to the students of class 12 science. From today onwards, I'm going to take you through a few lessons of chemistry. And to begin with, I'm going to start off with the chapter called Amines, which comes under the organic part of the chemistry. So before I begin, let me give you the outlines of the things that we are going to cover under this chapter. The first will be introduction to the group of organic compounds that we are studying, followed by the naming of these compounds. Then you will have the classification of the compounds, and then you will have the synthesis of these compounds and their physical properties, chemical properties, and finally their uses. So moving to today's chapter, first let me tell you what are amines. So amines are defined as the derivatives of ammonia. Ammonia has the molecular formula of NH3. So amines are obtained when you replace hydrogen of ammonia with an R or an AR group. R stands for alkyl groups and AR stands for aryl groups. So ammonia, if you replace the hydrogen atom with an alkyl group, alkyl means methyl, ethyl, propyl, butyl, etc. So from alkane, when you remove one hydrogen atom, for example, I'll take methane, and if you remove one hydrogen atom, you will get methyl. Similarly, ethane, C2H6, ethane. Now from this, if you remove one hydrogen atom, you will have C2H5. This is called as ethyl. So from alkane, if you remove one hydrogen atom, you will have your alkyl group. So depending upon whether you are going to replace hydrogen atom with an R or you are going to replace hydrogen atom with an AR group, AR refers to the aromatic compounds, which mostly consists of a benzene ring. So you can replace hydrogen atom with an alkyl group, or you can replace hydrogen atom with an aryl group. So if you replace hydrogen atom with an alkyl group, it is called as alkyl amines. And if you replace hydrogen atom with an aryl group, it is called as aryl amines. So all these amines are found in proteins, vitamins, a lot of drugs that are being used, and then you have dyes, hormones. All of this contains certain amounts of amine compounds in it. So proteins, which are made of amino acids, are all amine compounds. So that's why we are studying in detail about amines, because they play a very important role in our daily lives. So moving to the classification of amines. Classification of amines can be done in two ways. The first one is depending upon the number of hydrogen, the number of H atoms replaced, now depending upon the number of hydrogen atoms that has been replaced, it can be classified into primary amines, secondary amines, and tertiary amines. To give you an example, from ammonia, if you replace one of the hydrogen atom with only one R group, that is, you will have NH2R, where instead of one hydrogen atom, there is one R. So this is called as primary amine. And if you replace two of the hydrogen atoms from here, that is, instead of two hydrogen atoms, you will have two R groups, R2. So this is called as secondary amine. And if you replace all the three hydrogen atoms with three R groups, it is called as tertiary amine. So from NH3, if all the hydrogen atom has been removed and substituted it with R groups and R3, and it is called as tertiary amine. So this is how you classify amines on the basis of number of hydrogen atoms from ammonia, which has been replaced by R or AR group. So if one hydrogen atom has been removed, it is called as primary amine. And if two hydrogen atoms are removed and two R groups are introduced, it is called a secondary amine. And if all the three hydrogen atom has been removed and replaced it with three R groups, then it is called as tertiary amines. So that's how we have primary, secondary, and tertiary amines. Now, next classification is based on type of alkyl groups. The second classification is done on depending upon types of alkyl groups. Depending upon the type of alkyl groups, amines can be classified into simple amines and mixed amines. Suppose I have N. I have a tertiary amine over here, CH3, where you don't have any of the hydrogen atom because all the hydrogen atom has been replaced by three methyl groups over here. In this case, all the alkyl groups, the R groups are all same. All the R groups are CH3 over here. If all the R groups are same, it is called as simple amines. The mixed amines are the ones in which you are using different alkyl groups. Suppose I have taken an ethyl group over here and then I have taken a CH3. Again, I have taken C3H7 over here. So if you have a compound like this where three of the alkyl groups introduced are different from one another, such amines are called as mixed amines. Mixed amines refers to different alkyl groups. Alkyl groups attached to the nitrogen atom. Simple amines where you have same alkyl groups. If the alkyl groups are all same, it is called as simple amines. So that's about classification of amines. There are two ways of classification. The first one is based on the number of hydrogen atoms that has been replaced. You have primary, secondary, and the tertiary amines. The second classification is done on the basis of the type of alkyl groups. If the alkyl groups introduced are same, it is called as simple amines. And if the alkyl groups introduced are different, it is called as mixed amines. So that's concludes the classification part. Now moving to the nomenclature. Nomenclature where you're going to name all of these different groups of compounds. So you have studied in class 11 where we know that there are millions of organic compounds present. So until unless we give a name to these compounds, it's very difficult to identify one compound from the another. So there's an organization called as IUPAC. IUPAC, which stands for International Union for Pure and Applied Chemistry. Now, each of the organic compounds are named according to the rules set up by this organization called International Union for Pure and Applied Chemistry. So each of the organic compounds have two types of name. The first one is their common name or the general name, and the second one is their IUPAC name. So in the case of amines, the common name is given in the form of alkyl amine. Whereas in the case of IUPAC, the name are given in the form of alkane amine. So it's very simple to name. Suppose I'll give this example where I have CH3, CH2, NH2. Now the first rule for naming a compound is you need to calculate the number of carbon atoms present. So in this case I have 2 carbon atoms. So 2 carbon atoms stands for ethane. So if you want to give the name, common name for this will be alkyl amine. So alkyl, the The group of alkyl present over here is, you have two carbon atoms, so it is ethyl. So ethyl amine. So this will be, common name will be ethyl amine. Will be the common name. And the IUPAC name will be, it is alkane amine. The E of alkane is removed and substituted it with the word amine. So this will become, from ethane, this will become ethane amine. So instead of E of ethane, you are going to write the word amine. Ethane amine. So that's how you are naming the different compounds of amines. Common name, alkyl amines. IUPAC name, it is alkane amine. Now I'm going to solve some questions based on classification of amines and nomenclature of amine compounds. Moving to the first question from the in-text. They have given 4 compounds. You need to identify which are primary amines, which are secondary amines, and which are tertiary amines. So before that, I want you to remember that depending upon the number of hydrogen atoms which is left on the hydrogen atom, you are going to classify into primary, secondary, and tertiary amines. So here, ammonia has the molecular formula of NH3. Now, depending upon the hydrogen atom that has been removed, now here nitrogen has 2 hydrogen atoms, which means one of the hydrogen atom has been replaced by this working group over here. So that means one hydrogen atom is removed. So it is primary amine. And in the second one, none of the hydrogen atoms are present on nitrogen atom because all of that is being replaced by 2 alkyl groups and 1 aryl group. So therefore, this is tertiary amine. And if you look at this compound, this nitrogen has 2 hydrogen atoms, which means only one has been removed. Therefore, again, this will be primary amine. And in this case, 2 hydrogen atom has been removed and one is still there on hydrogen atom. Therefore, this is secondary amine. So that's how you classify amines into primary, secondary, and tertiary amines. Now, moving to the next question, it says, name the following compounds. So, before you name the compounds, you need to remember the set of the rules that we have studied in class 11. So, the first thing that you're going to do is you're going to count the number of carbon atoms. So, here in this case, you have 2 carbon atoms, and the functional group present is your amine, NH2. So, 2 carbon atoms stands for ethane. So, this will be ethane. But as I said earlier, instead of E, you are going to write down the name of the functional group over here. So, this will be ethane amine. Alkane amine. For the common name, it is alkyl amine, but for the IUPAC, you have to write alkane amine, as I've discussed before. Now, in this case, first count the number of carbon atoms, 1, 2, and 3 carbon atoms, which stands for propane. And you have an amine group over here. So, in this case, you need to indicate the position of the carbon atom on which amine is present. So, amine is present on first carbon atom, second carbon atom. On the second carbon atom, amine is present. So, therefore, remove this E and write the number 2 and then amine. So, propane to amine. So, moving to the next one. Here you have a link on which NH2 is present. So, therefore, this will be benzene amine. Main tile rose carbon atom carbon carbon propane carbon butane carbon digi functional group functional group NH2 NH2 carbon it is not necessary that you are going to show the number. If the NH2 group is present on a carbon atom which is somewhere in the middle, then you need to indicate the number on which NH2 is present. Di chidi sambala di la carbon sonto, sumula di sambala in NH2 di carbon consolato. Iva la tua, di chidi propane to amine. Di nano la benzene amine. Benzene nana di gana benzene c'è, benzene gana valore NH2. Di carbon tango ini pare, tango ina tango te umare. Amine, benzene amine chiusa sambi kare te umare. Amine nisa di kare, haja tango res. Now moving to the next topic, which is the preparation of amines. So here we have done with introduction to the group of compounds called amines, and then we are done with classification of amines, and then we are also done with naming of these compounds. Now moving to the next topic, which is preparation of amines. Under preparation of amines, there are different methods to prepare. The first method is reduction of nitro compounds. And the second one is reduction of nitriles. And then you have anaerosis of alkyl halides. Of alkyl halides, RX, which is also called as alkyl halides. And then there is reduction of amides. Then there is Gabriel phthalimide synthesis. And finally, there's Hoffman bromamide degradation. Hoffman bromamide degradation. So these are the 6 methods that we are going to study. So before that, you need to understand what is reduction. Reduction means removal of oxygen atom and addition of hydrogen atoms. So here, nitro compounds. The nitro stands for the term NO2, nitro groups, and nitrile stands for the group CN. And anaerosis of alkyl halides. Alkyl halides means you have an alkyl group. Again, alkyl means methyl, ethyl, butyl, pentyl, which is all connected to a halogen atom. So whenever you have alkyl group, suppose I'll say methyl group, which is connected to a halogens, which belongs to the group 17 amines. So I will say chlorine. So this is a methyl chloride. So methyl chloride is a member of alkyl halides. Similarly, I can have ethyl C2H5, and instead of one hydrogen atom, you have a halogen. So if I write bromide over here, so this is the ethyl bromide. So these are examples of alkyl halides. So in case of anaerosis of alkyl halides, the term itself indicates mesos means breakdown, and amino refers to ammonia. So you're going to break the bond between this carbon and halogen with the help of ammonia. That's why it's called as anaerosis of alkyl halides. Then you have reduction of amides. So it is important that we need to differentiate between amines and amides. So amides are the compounds where you have alkyl group attached to a carbonyl group, C double bond O, and then you have a amine group over here, NH2. So whenever there is a carbonyl group present, it is called as amide. Whereas RNH2 is amine, where you don't have a carbonyl group in between R and NH2. Whereas if you have a carbonyl group present between R and NH2, it is called as amide. So it is important that you identify or you know the difference between amide and amines. R and H2 is amines, whereas if you have a carbonyl group in between R and NH2, it is called as amide. So reduction of amides means you are going to remove the oxygen atom and instead you are going to put hydrogen atoms over here. So next one is Gabriel Thalomite synthesis. So Gabriel is the name of the scientist who discovered or who introduced this method, followed by Hoffman bromide duplication again. Where Hoffman is the name of the scientist who discovered this method. So I'll go one by one now. So under preparation of amines, I'm going to discuss the first method called reduction of nitro compounds. Okay, sorry, this is A, not E. Okay. Now, reduction means removal of oxygen atom and addition of hydrogen atoms. Nitro compounds are the compounds which have NO2 group in them. NO2 as a functional group. So what happens is, under reduction, there are two methods to do reduction of the nitro compounds. The first method is chemical method. And the second one is catalytic method. So under chemical method, metal plus HCl is used as the reagent. So let me take an example of C2H5 NO2. Now when you treat this with a metal plus HCl, now metal can be tin or iron. Now when you reduce a nitro group with by treating it with metal plus HCl, the NO2 gets converted to C2H5 NH2. So NO2 gets converted to NH2. Now under catalytic method, suppose I'll take nitrobenzene. Now when you add hydrogen in the presence of a catalyst, which could be nickel, platinum, or palladium, any of this. Now, catalytic method means you are using a catalyst which speeds up the reaction. Now, in this case, you are adding hydrogen with the help of a catalyst. So, NO2 again gets converted to NH2. So, the nitrobenzene gets converted to benzeneamine, which is generally known as amine. So this is the common name of this compound, whereas benzeneamine is the IUPAC name of this compound. So out of the chemical method and the catalytic method, chemical method is generally preferred because the FeCl to produce in this reaction, undergo hydrolysis to produce HCl, due to which only a small amount of HCl is enough to initiate the reaction. So with this, we are done with the first method. Now coming to the second method, which is reduction of nitriles. Okay. Now on the reduction of nitriles, let me take an example of RCN with the help of H2 and the catalyst platinum. The RCN gets converted to RCH2 and H2. So let me take an example for this. CH3, C triple bond N. When you add hydrogen in the presence of nickel as the catalyst, it gets converted to CH3, CH2, and H2. So you are getting an amine which has one more number of carbon atoms. Here, the alkyl group consists only of one carbon atom, but in the product you are getting alkyl group with two carbon atoms. So this method is used for preparation of essence of amine compounds. That is, if you want to convert methane amine to ethane amine, which is increased by one carbon atom, we will use this method. So let me explain the mechanism for this reaction. Now in this method, what happens is, you have your CH3 to group N. When you add hydrogen atom in the presence of the nickel as the catalyst, what happens is, this H2 consists of H plus and H minus. Now this hydrogen atoms will get add to carbon atom and the nitrogen atom. So how does it happen is that the pi bond over here shifts to the nitrogen atom because it is more electronegative. So nitrogen will have a negative charge and this carbon will have a positive charge. Now this positive charge will attract the negative hydrogen from here, and this nitrogen will attract the positive hydrogen like this. So you will get CH3, CH, double bond, and H. So you can see that one bond has been broken and instead two hydrogen atoms get added. Now again, you need to break the double bond over here. So again you add a molecule of hydrogen atoms with the presence of nickel as the catalyst. What happens is, again this hydrogen consists of H plus and H minus. Again, this nitrogen will pull the bonded electrons towards itself and it will have a negative charge, and this carbon will have a positive charge. Now this proton, hydrogen with a positive charge, will attack the nitrogen with a negative charge, and this H minus will come and attack the carbon with a positive charge. So what you get is CH3, CH2, and H2. So this is the main product that we are trying to prepare. So this is ethane amine. You need to count the number of carbon atoms, 1, 2. So 2 carbon atoms means it is ethane. You have amine group over here. So instead of E, just add the word ethane amine. So that's how you have converted nitriles to amines by adding hydrogen atoms with the help of a catalyst. So this is about reduction of nitriles. This method is used for converting methanamine to ethanamine, ethanamine to propanamine. Whenever you need amine with one more carbon atom, we use this method. So this is very useful in conversion of the organic compound from one to another, which we'll discuss later. Okay, now coming to the third method. Okay, then the next method is aminolysis of alkyl halides. The name itself indicates that ammonia means ammonia, NH3, and this is means breakdown. So Rx is called as alkyl halides. Again, this is a group of organic compounds. Now, alkyl could be any group: methyl, ethyl, propyl, butyl, etc. And X stands for the elements which belongs to group 17. So here in this case, I have an NH3 group over here. Now when NH3 group reacts with an alkyl halide, Rx, now this X being more electronegative pulls the bonded pair of electrons towards itself, and X will have a negative charge and this R will have a positive charge. Now this N of ammonia has a lone pair of electrons which makes this electron rich. So this electron rich ammonia acts as a nucleophile, and this R with a positive charge will attack the lone pair of electrons on the nitrogen atom, and you will get H3N, R, and losing its electrons in forming bonds with this R will have a positive charge. Now this positive charge is stabilized by this X minus over here. Now what happens is, when you treat this compound or the intermediate with a base, NaOH, now NaOH consists of two parts, a negative part and a positive part. Now Na is the positive part and OH minus OH is the negative part. Now what happens is, this Na plus will attract the X minus over here, will go and combine with X minus, and this OH minus will pull one of the hydrogen H plus, a proton from this nitrogen atom, and in the process a water molecule is removed. This OH with a hydrogen atom from here, H2O is removed, and this Na will combine with this X, and a sodium halide is removed. So what you are left with is H2 and R. So you are left with 2 hydrogen atoms over here. You had 3 hydrogen atoms in the beginning, but at the end you have 2 hydrogen atoms, and in the place of 1 hydrogen atom there is an alkyl group introduced. So recalling what we have studied before, so this belongs to primary amine. So this is how you are preparing amine by using ammonia and an alkyl halide. Now this method can also be used to prepare or converting primary amine to secondary amine to tertiary amine. The thing is, if you don't stop the reaction here, the reaction keeps on going on. So the primary amine again will react with Rx. Now, X being more electronegative will have a negative charge and R will have a positive charge. Now, this R positive will attract the lone pair of electrons on the nitrogen atom, and this X minus will again combine with this. Now, you will have H2, N will have a positive charge because N is losing its lone pair of electrons and forming bonds with this R. So, N will have a positive charge, and then instead of 1 R, now you have got 2 R, and this positive charge is stabilized by X minus over here. Again, same thing, you are going to treat it with NaOH, which consists of Na plus and OH minus. Now this Na plus will attract the X minus, and this OH minus will pull one of the hydrogen from here. So you are going to remove a water molecule, and you are also going to remove NaX from here. So you are left with R, so 1H, and 2R. So this is your secondary amine. You have removed 2 hydrogen atoms and you have introduced 2 alkyl groups over here. So this is your secondary amine. Now again, if you react this with another Rx molecule, what happens is the same process is repeated. This nitrogen with the lone pair of electrons will attract this R with the positive charge, and this X minus will again combine with this to form an intermediate. Now this R, now you have 2 R, now it becomes 3 R. So you will have N R3, and N will have a positive charge which is stabilized by X minus over here. Now when you treat this with, sorry, H is still there. Now when you treat this with NaOH, this OH minus will pull the hydrogen over here, and this Na will combine with X, and a water molecule, and NaX is removed. Sodium halide is removed. Now what you get is you will get NR3, which is your tertiary amine. So you can see that in this method you are getting a mixture of primary, secondary, and tertiary amine, and that is the disadvantage of this method, because whatever we prepare something, we always try to prepare that in the pure form. So in order to overcome this disadvantage, what is being done is either ammonia is taken in excess. If you take ammonia in excess, primary amine will be the major compound form. Primary amine will be the major product. And if you take alkyl halide in excess amount, your tertiary amine will be the major product. Ammonia gi nanola nitrogen kana lone pair electron yorwa. Electron gi yezam ko electron rich the electron mabu yedu samala ko electron mu aisa chila attack chitu nendo tu dorwa. Ta dechine na Rx alkyl halide ji ko nendo la tu samala khales tu gore na. R gana positive charge leader, courage in the na X the electronegative charge, ko the electron dela ni yedu the corner sama ti worwa. X gana negative leader, R gana khale positive. Ta the positive the R N gana electron ni yedu jorwa. Odi ne kara nikima bond chayre. Ta those nitrogen electron the ko yedu samala nitrogen electron show yedu samala nitrogen gana khale yedu na positive chile. The positive destabilized X minus chile. These so product so right in the line NaOH in the trichiba. Any gonna positive check OH gonna negative. The NAD positive dig in negative X the market OH negative dig in H plus chicken. It is some also hydrogen so many sequence for hydrogen hydrogen. Any nitrogen check any R check. The hydrogen primary amine. The primary amine the young RX into reaction. The reaction the mood in the group. The RX in the produce of a young R the nitrogen gonna lay any nitrogen gonna positively any positively stabilized shell X minus lead. I am here a product the rest in the NaOH in the fridge with some other NaX minus liquid water OH the hydrogen liquid. Those changing H and not 2 with the hydrogen secondary amine. I am RX in attack children sabala and Tamagalama Karana MR3 Karana tertiary amine. The big number primary, secondary, tertiary, Sundia correct. Mixture chilla. The India also mixture go Mariana, primary go Chazayana, Harry secondary and tertiary. The mixture chimara is the line of the Karichide. Yama, the Mamukire, Yama, Hare Mamukire, RX Mamukire. The ammonia, the Mamukina, not a product, Halima, primary the Mara. The kissing the RX, the Makina, not a Halima, tertiary the Mara. Okay, that's all. Now moving to the next method. Okay, so under reduction of amines, first we need to know the difference between amines and amides. So amines and amide have a carbonyl group present between R and the NH2, whereas in the case of amines, there is no carbonyl group present. So moving to the reduction of amines, reduction means removal of the oxygen atom and addition of hydrogen atom in general. Now in this case, we are going to add hydrogen atom in the presence of a catalyst because, as we have discussed earlier, catalytic method is being used. Now, here what happens is you need to make space available for the incoming hydrogen molecule to come and attack. So for that, what happens is always the reaction initiates in this way. The double bond shifts onto the oxygen atom. O will have a negative charge and C will have a positive charge. So this step is repeated until you get R, CH2, and H2. So you are going to get amine in this group. Now let me explain the mechanism over here. Okay, instead of R, let me take C2H5, C double bond O and H2. You can take any alkyl groups over here. So now when I add hydrogen atom to this in the presence of nickel, this H2 consists of an H plus and H minus ions. Now what happens is this pi bonds over here shifts onto the oxygen atom. So whenever this pi electron shifts, that element will get a negative charge. So O will have a negative charge and this carbon will get a positive charge because it is losing its bonded electrons to the oxygen atom. Now in this case, the negative will again attract the positive part. So H plus will come and sit on this oxygen atom and H minus will come and sit on this carbon atom. So you will get C2H5, C, OH, and then you have one hydrogen and then NH2. So again, now what happens is the H plus, when you have H2 in the presence of nickel, now from this, H plus will come and attack this oxygen atom because oxygen normally has two lone pair of electrons. So this is rich in electron. So this H plus will come and attack this oxygen atom and it forms C2H5, C. O will have two hydrogen atoms now. Since O is losing its lone pair of electrons towards this hydrogen atom and forming a bond with it, now this O will have a positive charge. O gets a positive charge and then you have your NH2 and then this hydrogen atom. Now what happens is any electronegative elements like chlorine, oxygen, fluorine, they cannot have positive charge. Whenever they have positive charge, it is very unstable. So this oxygen having positive charge is very unstable. So in order to stabilize itself, what happens is this will leave in the form of water molecule by taking this bonded electrons. So this oxygen will take both the electrons and it leaves in the form of water. Now carbon is losing its bonded electrons to the oxygen atom. So now carbon will have a positive charge. Now on this positive charge, the H minus will come and attack this carbon. So you will get C2H5, CH2 and NH2. So this is what we are trying to prepare. This is the amine that we have prepared by using ethyl amide. So amide di kharla gupore na amine la gupore. So amide da amine ni khebata wala china amide la khari ore R da NH2 ni gimala C double bond O dire. This is called amide la. The amines nalola was diamine C double bond O diamine. So this is amine. So the reaction nalola also amide the amine la gupore. So the grade de la also khari pije chugore na. So VO the mapping hydrogen dongo. Hydrogen domela also khadi na venom hydrogen khadi na also H this samara also khadi pije chugore catalyst pije chira. Adala catalyst nickel pije chidwa. Ta nickel mare nickel chupu chimane. Platinum pije china dire palladium pije china dire. So the reaction chunda ni khade chugore na. Ta di na carbon kana da double bond O redo java. Ta di hydrogen di chilo la java. Ta di number 3 na such a so. Such as Lani, there are double bond to the ya organa drop, organa karikana data, negative form. And the carbon the bond electron, positive electron, the should be this carbon gonna charge karibidana, positive D, organa karibidana, negative D. And the negative D hydrogen positive D, and D positive karibidana, hydrogen negative D. Those chinana karidaso C2H5, COH, and H. This as well. So, you get the multi-neutral reaction. So, hydrogen is H plus H plus theta co-electron ma is a ma the organ electron sheet had it. Then a lone pair of electrons is bonding on a chashe money then a lone pair of electrons. And the lone pair electrons being found the reduction into the bond is here. Now all the electron the part reduces and all the electrons we know reduce all kind of charge positive. The elements oxygen, nitrogen, fluorine, electronegative elements so the positive charge layer. So the layer needs some layer unstable. The stabilized stabilized electron rather chair the children. The carbon number 2 bond the electron the key water molecule number 2. The carbon the electron the shows pointed electron the and carbon charge positive chile. The positive the H minus chile and C2H5 CH2 NH2. Okay, so another method can also be used or by using lithium aluminum hydride. Lithium aluminum hydride is the common reducing agent. Project machine deep reagent H minus to this. So lithium aluminum hydride can also be used instead of hydrogen in the presence of nickel. Okay, so with this we are done with this method. Now coming to the fifth method. Okay, next method is Gabriel thalamide synthesis. Gabriel is the name of the scientist who discovered this method. Now, in this method, first you need to know the molecular formula of thalamide or the structure of the thalamide. Now, in case of thalamide, you have a benzene ring and 2 carbonyl group attached to it, which are again connected by an NH group. So this is the thalamide. Now, in this, 3 steps are followed. The first one is by treatment with KOH. and then by treating it with RX, an alkyl halide, and finally by treating it with NaOH. So in this method, you are getting a primary amine, RNH2. You will always get a primary amine, and the byproduct form will be sodium salt of halic acid, C double bond O, C double bond O, ONA plus and ONA plus. So sodium salt of halic acid is formed. This is sodium salt of halic acid. So again, let me explain the mechanism for this. How does this reaction happens? Okay, you need to remember that this method is used only for the preparation of primary amines. Primary amines, that too, only alkyl amines. You cannot prepare aromatic primary amines from this method. Aromatic primary amines cannot be prepared by this method. The reason for this is, if you take ARX instead of R, here, if you take ARX instead of RX, ARX will not undergo nucleophilic substitution with amine formed by this thalamite. So therefore, it is used only for the preparation of primary amines, not for the primary aromatic amines. Okay, now coming to the mechanism of this reaction. Okay. Three steps are involved. Step 1, when you treat thalamite with KOH, C double bond O, C double bond O, NH, when it is treated with KOH, what happens is, this OH will take away this hydrogen atom and it will form a water molecule. And instead of H, this K will come and sit over here. So you will get C double bond O, C double bond O, and instead of hydrogen, the K comes. Okay, that is the first step. Now the second step is, okay, step 2. C double bond O, C double bond O, NK reacts with RX, any of the alkyl halides. Now again, this K will take away this X minus, this R positive will take the place of K. So you will get C double bond O, C double bond O, and R. Now the next step is, step 3 is where C double bond O, C double bond O, and R reacts with 2 NaOH, 2 moles of NaOH. And what is being produced is RNH2, a primary amine is produced, and also a sodium salt of halic acid is produced as the byproduct. So C double bond O, C double bond O, ONA. So this is your primary amine, and this is the sodium salt of halic acid. Okay, तर तिने तिचे घेवायची नंतर ही रिएक्शन दी चुना स्टेप सुनिले स्टेप थांबो देला खाली ना थैलीमाइट कजी थैलीमाइट है ना benzene C double bond O C double bond O NH with the thalammite che might है ना amite ला को बोला amite है दी सबला AR by N Kimala Fatina Kari C double bond oil. So that's why this is called as thalamide. Thalamide the KOH in the trichi, KOH in the chisa and RX in the check, and Tamadilla super de la Parijana, NOH in the trichi. Okay, the Dina Rich Gorelana, hydrogen and the hydrogen jitwa, the hydrogen the potassium hydroxide the OH minus jilva, BH plus the OH minus methane water molecule. BH pizza ba khali dena K dena ka the jo kya water ta dusni ngala NK raswa NK rago the anga also RX in the rich to sambala X negative with R comma positive. So the R positive the ani K pizza bali the K the current X in the chini chlorine in a potassium chloride ani bromine in the china potassium bromide form nama and can arrive in also N nebula R equal to that. Shaba samachi pachina neba. Sama N R equal the ani thamatela NaOH in the rich to sambala khari OH kana negative che and kana positive delta. The sodium hydroxide is a base to the form. But the rich to sambala hazola product uni rai de khare primary amine diva ani the primary amine matte varachina R ani NH2 ko bahala primary amine na R N and hydrogen need the R NH2 ani ONA has ONA the bond break chi ONA chick the bond break chi correct ONA chick don't change the banana yard and gila halidelana sodium salt of phthalic acid. Okay, moving to the final method, that is often bromamide degradation. So this is the final method of preparation. So Hoffman is the name of the scientist who introduced this method, and under this reaction, what happens is amide is converted to amines with the help of bromine and NaOH, say 4 moles of NaOH, and the product being formed is a primary amine RNH2 plus NABR plus Na2CO3, a sodium carbonate plus H2O. So when you balance the equation, you have 4 moles of sodium over here, and you have got only 3 moles. So in order to make it equal, you're going to multiply this with 2 and 2 water molecule. So the amide is being converted to amine by treating it with a bromine molecule. So the name itself indicates bromamide degradation. You are degrading this amide with the help of bromine. So these are very chungola. So amide ki namla C double bond O jala. Odi biya asini azo di khari na dugo na amines se sugola. The amines as it is a also piju che di khari piju che na bromine piju che dwa. Each ne ko ni na khari ta na Hoffman bromamide degradation. So with this, we are done with the preparation methods of amines. The deloxy na na the bado khari kari chana na habotela amines na khande chala lagi ne and amines the khades ever chugone classification number na khari kari chana also based on number of hydrogen atoms that has been replaced, primary, secondary, and tertiary amines, and it, depending upon the type of the alkyl groups, simple amines and mixed amines. Classification chidani che. And the jugular naming of the organic compounds also mean this town. The Thailand was IOPAC rules to follow Chugula. And the jugula, and we started off with the preparation of amines. Amines is the method true reduction of the nitriles, then you had a reduction of the nitro compounds, aminolysis of alkyl halides, and then reduction of amides, and then you had Hoffman bromamide degradation and Gabriel thalamide synthesis. These are two being also solved. Now let me solve some of the questions based on this preparation. Maybe the question asks a conversion from this part. Say, convert benzene to aniline. You have to convert benzene to aniline. For that, first you have to know the structure of benzene, and you also have to know the structure of aniline. The structure of benzene is like this, and aniline, benzene with NH2. Now you are supposed to introduce NH2 group from this benzene ring, which you cannot do it directly. So out of the 6 methods that we have studied under preparation of amines, if you have a nitrobenzene, you can do reduction of nitro compounds, and then the nitro group is converted to amine. So therefore, first thing you have to do is you have to think about converting benzene to a nitrobenzene. So benzene when treated with concentrated HNO3 and concentrated H2SO4. Now this reagent is called as nitrating agent. The role of nitrating agent is it introduces NO2 group on the benzene ring. So the benzene gets converted to nitrobenzene when you treat it with concentrated HNO3 and concentrated H2SO4. Now this is a nitro compound, nitrobenzene. Now under 6th method, we have studied reduction of nitro compounds where you are reducing NO2 to NH2 by treating it with H2 in the presence of a catalyst. Catalytic method can be used over here. So when you add hydrogen atom in the presence of a catalyst, that is palladium, this O2 gets reduced to NH2. So that's how you convert benzene into aniline. So you have to convert first benzene into nitrobenzene, benzene into nitrobenzene by introducing a nitro group with the help of nitrating agent, that is concentrated HNO3 and concentrated H2SO4, and then followed by reduction of the nitro group by treating it with hydrogen in the presence of a catalyst, that is palladium over here, and this nitro group gets reduced to NH2. So this is one type of question that's being asked. To N-dimethyl aniline, you have to know the structure first, that is the benzene, and then you have aniline, you have NH2 on benzene ring, but in this case it says N-dimethyl. N refers to the substituent. So this indicates that you have 2 substituents. The di indicates 2. You have got 2 substituent groups which are methyl groups. So methyl is CH3. So if you deduct the structure from this name, you get, instead of 2 hydrogen atoms, you have 2 methyl groups. So N-dimethyl aniline. So this is the base compound aniline. From aniline, 2 of the hydrogen atom has been replaced by the 2 methyl group. That's how you write down the IUPAC for the substituted amine compounds, N-dimethyl aniline. So what happens is, now you have to convert benzene to N-dimethyl aniline. Now how do you do that? So first thing, you have to convert benzene to nitrobenzene, concentrated HNO3 and concentrated H2SO4. It gets converted to benzene with NO2, nitrobenzene. The nitrobenzene again on reduction with the help of H2 and palladium as the catalyst, it gets reduced to aniline. Now from aniline, can you introduce 2 methyl groups? So for that, you need to again recall the method that we have studied in the preparation, that is the ammonolysis of alkyl halides, where alkyl groups get attached. So primary amines can be converted to secondary amine can be converted to tertiary amine. So in this case, this is a primary amine. Now you want to convert that into tertiary amine. So you will add alkyl halide to this. So alkyl group that we need over here is a methyl group. So you are going to introduce CH3. So alkyl halide, say CH3I, methyl iodide. Now this I, you just have to recall the thing that this process we have started in aminolysis of alkyl halides. Now what happens is, this being more electronegative, this will carry a negative charge and this will carry a positive charge. Now this positive will come and attack this nitrogen with a lone pair of electrons, and you will have NCH3 and then 2 hydrogen atoms. I'll write it this way. 2 hydrogen atoms, since nitrogen is losing its lone pair of electrons to this carbon atom, and will have a positive charge. Now, any element in the sense the electronegative elements cannot have positive charge on them. So you need to stabilize the positive charge over here. So in order to stabilize the positive charge on the nitrogen atom, one of the hydrogen atom will leave in the form of H+. It means it is not taking these electrons. So these electrons are given back to this nitrogen atom, and it sits in the form of lone pair. So you will get NCH3 and then 1 hydrogen atom, and the lone pair of electron is back over here. Now you have introduced 1 methyl group, but you need 2 methyl group. So primary amine is converted to secondary amine. Now again you need our CH3 group over here. So for that, again you will treat it with CH3I. Now this I being more electronegative will carry a negative charge, and C will carry a positive charge. Now this carbon with the positive charge will again come and attack the lone pair of electrons on nitrogen atom, and you will get, okay, I'll write it on the top. Okay. We have on treatment with CH3I. Okay. Now this I carries a negative charge because it is more electronegative, and this CH3 will carry a positive charge, and we have this methyl group over here and H with the lone pair of electrons. Now what happens is, this carbon with the positive charge will come and attack this nitrogen with the lone pair of electrons, and you will get CH3 and hydrogen atom with a positive charge. Since nitrogen cannot have positive charge on it, so the hydrogen atom will leave. This hydrogen atom will leave, and this bonded electron is given in the form of one pair over here. So you will get CH3 and a lone pair of electrons back on the nitrogen atom. So that's how you have converted benzene into NN dimethyl benzenamine or amine. So that's how you converted benzene to NN dimethyl benzenamine. But in a hurry, the Tivana Karidar, benzene the NN dimethyl benzenamine Nagula. That the benzene the Nadilla Gura, direct Gura, the Katina of Haven Seola. The preparation of method Cho Java, Cho Jango on the Jango is there a Pijuche. That then also benzene color, nitrogen for a yoma, the ammonia can carry some of the nitrogen the Kovana lake is some of the the nitrogen the lake anything less over benzene the anything less over benzene the anything la Kaduna Katus where we did some of the nitro group the introduced to the NO2 the introduced chip NO2 the plates are not one reduction of nitro compounds as you are the method preparation of reduction of nitro compounds chain and NO2 the Karala China NH2 Latin the NH2 Latin Chazana Mozo Latin Karidana anything the Karila kanwa chule nazo N dimethyl adisabala hydrogen ni di ma pi ne digi sabla na kharilu re methyl group. Tadi primary redwa di na primary amine di tertiary amine redwa di hydrogen che amine sabala primary ni tertiary la so na azu method khari ju chi de na preparation na la method suba aminolysis of alkyl halides la ju hodi ju chi de ta hodi ju chi la ta alkyl halides chi ne treat chi ko treat chi la alkyl group khari ko na ala methyl group ko ba te chi ni methyl iodide dikhi ani I minus CH3 plus khajina na I di electronegative side ko na negative che CH3 gana hare positive D positive the nitrogen gana electron ni unit do de la ko ye attack chi ni ani NCH3 hydrogen ni diche ta nitrogen ki electron ni bi ko la biju chis ka and nitrogen gana charge hare dire positive nitrogen da oxygen da fluorine do la positively mare de na hare chen no ko electronegative unit samala ko so negative form na ko la ta di negative na ja le chi do ya ma parang not pair electron di chu ra chi do khare chi de ta hydrogen chi di H+ na ma do re de la electron ni di do ba odi not pair na ja di re de na dos chi ni hydrogen chi ki sabla alkyl group methyl di leswa ta di raja ha methyl group yanga chi ko ba ani methyl iodide yanga chi na do react chi ni na ni I di negative CH3 deposited CH3 di hydrogen na li nitrogen gana positive charge dile ta di positive dinya as well and hydrogen di H+ na te di bonded electron di kare nitrogen gana dile ani mazula koedi ara re N dimethyl benzene amine. So these are the two problems that I wanted to solve based on the preparation of amines. Write the equation for converting CH3 CH2 Cl to CH3, CH2, CH2, and H2. That's what I said. Dela carbon need wa, carbon need che. Dela carbon kazuto, carbon sum wa, emin digi na wala. Ta carbon ni ne, carbon sum la guru na ani ngazo. Method 2 na wo ne khandi piju chege na reduction of nitriles la jiwa CN ne ge piju choga. CN ne ge piju china ani kera amines carbon chik ma ego dirawa. This is a thousand Karisama Tower and CL big sabla CNG introduced chair some tower. But the chair lining reagent CH3 CH2 CL reagent Karin and the treat chorana CN Rala KCN number treat chine and DCLD K number turn to the CLD sabla solidana CND. So you will have CH3 CH2 CN di nitrile ra. Ta di nitrile ra sa vejula now ani azo khari china detail and the reduction of nitriles ready. Reduction of nitriles chela you can use addition of hydrogen in the presence of a catalyst. The method is this cheni carbon ki kimala carbon the nitrogen ni kimala bond sumyoba. Bond sumedo ne bond check the break chi hydrogen ni do yanga bond check the break chi hydrogen ni do chejwa taran chi ni kena la khari rangana CH3 CH2 CH2 and H2 dos chini mazo chlorine di ammonia la nitrile acid nitrate se sanar ba mazo chance rati reduction of nitriles to amines na wala method also hydrogen da nickel position ni gradient di che dos chini ani bond check cha hydrogen check yanga bond check cha hydrogen check chini and last kana right the amine ki mean che la rachana carbon ni da chlorine ne du samala this is called as chloroethane ani chloroethane di casein ne the trichi ani kana ethane nitrile rache di jula ani mazura di kare na it is carbon check carbon ni carbon sum it is called as propane and e di mapi ne e gitsa la kare na amine di mazula chundu di kare na propane amine. So with this we are done with preparation of amines. That other also kare jana na when amines na hale chila lagi me amines the amines the proteins na hormones the na ani me mangu chigi na ma amines compound de buji chigo re and ne chula ma zo amines the ever chita khade ne amines ever chita na ene ni yo ma di hydrogen changa la ta ni primary secondary tertiary che ni wa de la khare la na alpha group ya na aryl group introduce chido di chipa chika inga china simple amines che kisi alkyl the aryl group introduce chido di lo wa inga china mani mixed amines to chini ever chita ni che and this rule also the preparation of amines leaking the drug the drug in the reduction of nitrous compounds and in the reduction of nitro compounds and suba the amylosis of alkyl halides shiva the reduction of amides and nava the gabriel synthesis che the also Hoffman bromide degradation and this and this should also question the next class lani chemical properties, the physical properties and my earnest request for you is to read the textbook, solve the in-text question and watch the video again for your better understanding. Thank you.